Wow. Wow, crayfish. Wow.
When word spread that Australian farmers were dumping millions of crayfish into their rice fields, headlines called it a joke, critics branded it desperate, and social media had a field day.
Australian farmers were dumping millions of crayfish into their rice fields. It was part of a new project of theirs. The whole world laughed when they saw it.
Crayfish farming in rice paddies? What's next? Kangaroos in vineyards? But 1 year later, the mockery fell silent. The results were not just surprising, they were groundbreaking. Yields soared, profits doubled, chemical use plummeted, and ecosystems began to breathe again. For the farmers who took the risk, the message is clear. It's done. A new chapter in sustainable agriculture has begun, and it all started with a move that seemed absurd, until it worked. Why move crayfish into rice? At the heart of this unlikely agricultural revolution was a desperate problem. Australian rice farmers were facing mounting challenges: dwindling water allocations, falling market prices, and increasing pressure to cut chemical inputs in the face of environmental scrutiny. Regions like the Riverina, once flush with high-yielding rice crops, were now dotted with abandoned fields and struggling farms. As climate variability and regulatory tightening squeezed the industry further, farmers and policymakers realized that something had to give. Innovation wasn't just welcome, it was necessary. Enter the crayfish. Ironically, the solution was lurking right beneath their feet. Charax quadricarinatus, known as redclaw crayfish, is a freshwater species native to northern Australia, prized for its high protein content and fast growth in warm, shallow waters. Historically cultivated in tanks and ponds, redclaw had rarely been considered for co-culture with rice, but across the Pacific, a quiet agricultural revolution had already begun taking root. China had spent the last 2 decades perfecting the rice crayfish farming model. In provinces like Hubei and Jiangxi, millions of hectares were turned into aquatic agrarian hybrids where rice and crayfish thrived side by side. The results were staggering. Yields of both rice and crayfish rose, chemical inputs dropped, and farmers earned more from a single acre than ever before. The rice crayfish, RACE system, became a national symbol of eco-friendly farming, pulling tens of millions out of poverty and into a new rural middle class. The system was so successful that other countries, Vietnam, Thailand, even parts of the US, began adopting the model. Australia took notice. Researchers at institutions like the CSIRO and Southern Cross University began examining whether Australia's unique landscape, water use, and crayfish genetics could support such a system. The biology made sense. Crayfish feed on detritus, weeds, and small aquatic pests, reducing the need for chemical pesticides and improving the health of the water. Their waste acts as a natural fertilizer. Their movement aerates the soil and stirs nutrients. Most importantly, they provide a second harvest that could dramatically boost farm incomes. The idea was bold, but it wasn't without critics. Would crayfish burrow into levees and destroy irrigation channels? Could they carry disease? Would they compete with native aquatic species or disrupt ecosystems if they escaped? And more fundamentally, could Australian farmers accept a system that looked so radically different from their traditional methods? Despite the skepticism, pilot programs were launched in select rice-growing regions. Tens of thousands of crayfish were introduced into test paddies under carefully controlled conditions. The plan was simple: mimic China's success, but tailor it to Australia's unique environmental constraints. For many, it seemed like a moonshot, but for those close to the trials, the early signs hinted at something promising. Still, public opinion remained skeptical until the first full harvest came in, and that's when the story began to shift. Science of the system. Why it actually works. On the surface, pairing crayfish with rice seems counterintuitive, like mixing oil with water, but dig a little deeper into the biology and ecology behind it, and the brilliance of the system begins to shine. At the core of this method lies a concept called mutualism, a relationship where both organisms benefit. In the rice crayfish system, the rice plants and crayfish create a tiny self-balancing ecosystem. The rice provides a canopy that stabilizes the temperature of the shallow waters and offers shelter from predators. In return, the crayfish become little custodians of the field. Crayfish are natural foragers. They feed on decaying plant matter, algae, weed roots, and small invertebrates, many of which are pests that would normally require chemical control. As they move across the field bed, their constant burrowing stirs the soil, breaking up hardpan layers, increasing aeration, and releasing trapped nutrients. This natural tilling effect boosts microbial diversity, and supports healthier, deeper root growth for the rice. But the real magic happens in their waste. Crayfish excrete nitrogen-rich droppings, which decompose and slowly release nutrients into the flooded fields. This natural fertilization process reduces the need for synthetic inputs like urea or ammonium nitrate, helping farmers lower their costs while also decreasing the runoff of harmful chemicals into nearby water systems. And that's just the beginning. Studies conducted by agricultural research institutes in China and replicated in Australian trials have shown that this integration can significantly reduce the environmental footprint of rice farming. Methane emissions, a major greenhouse gas produced in flooded fields, drop by up to 40% in rice crayfish systems due to changes in microbial activity and increased oxygen levels from crayfish movement. Nitrous oxide, another potent emission linked to synthetic fertilizer use, also sees a marked decline. What's more, the crayfish help control mosquito larvae, snails, and rice plant hoppers, cutting the need for chemical insecticides. In many trials, farmers reported using up to 60% fewer pesticides and herbicides, transforming what was once a chemically intensive crop into a more organic, balanced process. There are also water savings. Traditional rice farming involves periodic draining and reflooding, which consumes vast quantities of water. But when crayfish are present, fields are kept at consistent shallow depths, creating a microenvironment that conserves moisture and protects the crop during heat waves. The paddy water also doubles as the crayfish's habitat, eliminating the need for separate aquaculture ponds and reducing water waste. Beyond the chemistry and biology, there's an unexpected behavioral bonus. Rice plants in crayfish integrated systems tend to grow hardier. With reduced pest pressures, less competition from weeds, and more available nutrients, rice matures more evenly and exhibits fewer signs of stress. Fields appear greener, more vibrant, and they yield more. From a scientific perspective, this integrated approach isn't just a clever trick. It's a reimagining of how agriculture can work when it mimics nature rather than fights it. It borrows ancient wisdom. Polyculture farming systems have existed in Asia for centuries, and updates it with modern ecological knowledge. And perhaps most crucially, the system diversifies risk. Even in years when rice prices are down, crayfish remain a lucrative fallback. Their market value is rising both domestically and abroad, thanks to growing demand for sustainable low-carbon protein sources. A farmer who once relied on a single harvest now has two, and one of them happens to be crawling right beneath the surface. In Australia, the adoption of this system represents not just a novel farming technique, but a shift in mindset. It proves that productivity and sustainability don't have to be opposing forces. They can coexist in muddy water, where little red claws gently till the soil beneath a sea of green stalks, quietly rewriting the rules of modern agriculture. The bold experiment that raised eyebrows. When Australia officially rolled out its rice crayfish pilot program, reactions were mixed, and often mocking. The idea of filling rice paddies with millions of crustaceans felt more like an outlandish reality show stunt than a serious agricultural solution. Headlines joked about clover farming and muddy madness, while social media lit up with sarcastic memes of crayfish and hard hats helping farmers harvest rice. Skepticism wasn't just in the air, it was in the water. But behind the satire, a quiet revolution was brewing. The program began with targeted trials in New South Wales's Riverina region, an area known as the heart of Australia's rice belt. Backed by government funding, agricultural researchers, and bold farmers willing to take a risk, the plan was to integrate Cherax quadricarinatus, Australia's native red-claw crayfish, into a handful of working rice paddies. These were not random experiments. Each site was carefully selected for its water access, soil type, and proximity to irrigation infrastructure. To start, farmers were trained in how to modify their paddies to accommodate aquatic life. Shallow trenches were dug along the edges of fields to create deeper zones for crayfish to shelter during extreme heat. Inlets and outlets were equipped with fine mesh screens to prevent escapes. Stocking density was calculated down to the square meter. Too few and the system wouldn't be profitable. Too many and it could collapse under stress. Every variable was logged: water pH, temperature, ammonia levels, oxygen content, even the depth of crayfish burrows. Despite the rigorous setup, concerns remained. Farmers worried the crayfish would tunnel into levees and compromise field integrity. Some feared the additional workload would outweigh any profits. Others didn't trust that tiny crustaceans could really replace pesticides or fertilizers. "We're rice growers, not lobster wranglers," one farmer quipped to a local reporter. For the first few months, the fields looked no different than usual. The rice sprouted, the water shimmered, and if you didn't know what lurked beneath the surface, you'd never guess something had changed. But those working the land noticed small signs. Pest pressure was lower than expected. Weed growth was reduced. Water remained clearer longer, and occasionally a flicker of red claws would break the surface before darting back into the muddy trenches. Then came harvest season. Early yield data brought cautious optimism. Rice production was stable, no significant drop despite reduced chemical use. In some fields, it even improved slightly. And then, after the rice was cleared, came the second harvest, crayfish. With careful trapping and timing, farmers pulled hundreds of kilograms of red claws from each hectare, plump, healthy, and ready for market. That first season didn't change every mind. Some fields had setbacks, flooded trenches, poorly managed burrowing, minor crayfish mortality. But the overall results were far more promising than anyone expected. More importantly, the numbers spoke louder than the jokes. Dual income cropping had arrived, and it worked. The farmers who took the leap became unexpected heroes in their communities. Their neighbors, once skeptical, began asking questions, not in jest, but in earnest. How much did you earn per hectare? How much water did you save? What did you use instead of pesticide? And perhaps the most telling question of all, where can I get my hands on some of those crayfish? What began as an experiment soon started looking like a movement. And though the rest of the country hadn't realized it yet, the ripples of change were already spreading through Australia's agricultural core. The mockers had spoken, but now the fields would speak back. Fast forward, 1 year later, reaping the rewards no one saw coming. 12 months after the first crayfish were introduced into Australia's rice paddies, the results rolled in, and they were nothing short of extraordinary. What was once mocked as a crustacean circus in the fields had quietly evolved into one of the most promising breakthroughs in modern Australian agriculture. Fields that had long struggled under the weight of rising costs and erratic weather were suddenly alive, with grain, with income, and with unexpected life. For starters, rice yields were not only sustained, but improved. Across most trial plots, harvests increased by an average of 8 to 10%. The reasons were layered. Fewer pests meant healthier stalks, richer soil supported more vigorous growth, and the crayfish's continuous movement kept the soil from compacting. More air, more nutrients, more root health. Simple ecological mechanics. Farmers who had anticipated potential loss in yield due to this crayfish experiment now found themselves delivering larger hauls than in previous years. But it was the second harvest, the one crawling below the surface, that delivered the real surprise. In several trial sites, crayfish production reached up to 1,000 kilograms per hectare. With wholesale prices ranging from $10 to $15 per kilogram depending on size and grade, many farmers saw an unexpected profit surge. Some even doubled their overall per hectare earnings compared to traditional rice-only seasons. For small and medium-scale farmers teetering on the brink of debt, this extra income was transformative. It helped them pay off loans, reinvest in equipment, and in some cases, expand acreage. And it wasn't just about the money. Chemical usage, particularly herbicides and pesticides, dropped dramatically, in some cases by as much as 60%. The crayfish actively fed on weed seedlings, insect larvae, and organic debris that normally required intervention. Not only did this reduce input costs, but it also opened the door for some growers to begin marketing their rice as organic transition or chemical reduced, a premium niche in both domestic and international markets. Water use also saw notable improvements. Because crayfish require stable water levels to thrive, the need for constant draining and reflooding, a common practice in traditional rice farming, was reduced. This more consistent hydration reduced overall evaporation, and proved especially valuable in drought-prone regions where every drop counts. Environmental scientists monitoring the program were impressed. Soil quality metrics, including microbial diversity, carbon retention, and aggregate stability, all showed signs of long-term improvement. Methane emissions, a major byproduct of flooded rice fields, were found to be significantly lower in crayfish integrated plots, likely due to increased oxygen movement in the soil. In a country increasingly wary of its agricultural footprint, this was a win that extended well beyond economics. And the market? It loved the novelty. Restaurants in Sydney and Melbourne began promoting rice-field crayfish as a new gourmet delicacy, highlighting the sustainable, traceable, farm-to-fork nature of the product. Chefs praised the flavor of the red claws, comparing them favorably to imported freshwater lobsters. Export interest followed. Singapore and Hong Kong, already major buyers of Australian rice, began placing trial orders for crayfish as well, intrigued by the possibility of dual product imports from a single sustainable farm source. More importantly, the community dynamic around the idea began to shift. Those who had once laughed were now curious. Agricultural expos, once dominated by machinery and grain pricing, began featuring panels on rice crayfish co-culture. Farmers who had piloted the system were invited to speak, their once ridiculed stories now seen as visionary. "I thought I was crazy when I agreed to put crayfish in my patties," one farmer said during a field day presentation. "Turns out I was just early." Government agencies, seeing the economic and environmental potential, began investing further. New grants were launched to expand the program into other regions. Biosecurity protocols were tightened. Training sessions were rolled out to help more farmers adopt the system responsibly. And yet, beneath all the headlines and profits and accolades, one simple truth stood out. The land itself was healing. Where chemical runoff once leached into rivers, crayfish-filtered water now flowed clean. Where monoculture once dominated, a tiny ecosystem now pulsed with balanced life. The mockery had faded. The doubts had been washed away in irrigation channels teeming with claws and potential. 1 year later, the verdict was clear. What once seemed like a bizarre, even foolish experiment had turned into a model of resilience and reinvention. Australia had taken a gamble and won, and while some still chuckled at the headline, no one was laughing at the results. Because now, farmers weren't just growing rice, they were growing something far more powerful: hope. Broader impact: how crayfish in rice fields changed more than just farming. When the first reports of Australia's rice crayfish experiment hit the news, the headlines focused on novelty. Millions of crayfish crawling beneath stalks of rice in sun-scorched paddies. But as the results came in, the conversation quickly evolved. This wasn't just about clever farming, it was about transformation. And not just for farmers, but for entire communities, ecosystems, and the national conversation on sustainability. In the rural regions of New South Wales, Victoria, and parts of Queensland, where water scarcity, rising costs, and unpredictable weather patterns had long made rice farming a tenuous affair, the success of the rice crayfish model was nothing short of revolutionary. In towns like Leeton, Deniliquin, and Griffith, where empty storefronts had become common and younger generations were moving away in search of stable employment, the crayfish boom brought something unexpected: hope. With crayfish production came new industries. Hatcheries emerged to breed and supply juvenile red-claw crayfish to farmers, while local processing facilities expanded to handle both rice and seafood in tandem. Small family-run farms that had once teetered on the edge of bankruptcy suddenly found themselves with access to dual revenue streams, and more importantly, a reason to stay on the land. The labor demands of crayfish farming also opened up employment in areas that had seen steep job declines. Crayfish don't harvest themselves. They need regular monitoring, trap collection, sorting, grading, cleaning, packaging, and transport. New agribusinesses formed to fill those needs, many of them local, grassroots, and led by younger entrepreneurs who saw opportunity in the mud. Some former farmhands transitioned into aquaculture specialists. Others opened logistics companies, niche seafood restaurants, or cold chain export services. Local economies, once stagnating, began to pulse again. Even schools took notice. Agricultural colleges began to integrate rice crayfish modules into their curriculums, teaching future farmers not only how to grow food, but how to manage complex, integrated systems. Children who had once grown up assuming they'd have to leave for city jobs were now envisioning careers right there in their hometowns, modern, climate-smart, and profitable. But the impact didn't stop at economics. One of the most profound transformations was environmental. For decades, Australia's rice sector had faced heavy criticism for its water usage and chemical runoff. Critics pointed to dry riverbeds, disappearing wetland habitats, and declining biodiversity. But the rice crayfish system offered a compelling counter-narrative.
Call from rice farmers and crawfish farmers about when they rotate rice and crawfish in the same field.
By maintaining stable, shallow water levels and reducing the need for chemical pesticides and fertilizers, the new system began to breathe life back into the landscape. Fields that once emitted clouds of methane and drained aquifers now served as miniature wetlands. Native frogs, dragonflies, ducks, and even turtles returned to paddies that, just a year before, had been lifeless pools of stagnant water. Insects that played critical roles in pollination and soil regeneration flourished once more. Water quality improved downstream as runoff from the fields carried fewer nitrates and phosphates into the river systems. Some farmers were even able to earn eco-certifications or government sustainability credits, opening doors to premium export markets that favored lower emission and organically managed products. Perhaps even more remarkable was how this small-scale transformation began to ripple outward, globally. Soon, agricultural delegations from Southeast Asia, Sub-Saharan Africa, and parts of Latin America were visiting Australian trial sites. Countries like Bangladesh and Uganda, where rice is a staple but farming conditions are becoming more precarious, saw the dual harvest model as a potential lifeline. The idea that a single flooded hectare could produce both grain and animal protein, without damaging the land, held obvious appeal. In climate-vulnerable regions where food security was becoming a daily concern, the simplicity and scalability of the system made it attractive. Australia, long seen as a water-stressed, high-cost farming nation, suddenly found itself in the unlikely role of teacher. Workshops, virtual training sessions, and collaborative research projects were launched to help transfer knowledge abroad. Australian universities began working with international NGOs and food security programs to refine models for other climates, soil types, and cultural contexts. Closer to home, the rice crayfish model began influencing policy. Agricultural sustainability grants were reshaped to support integrated systems. Water use efficiency programs began offering incentives for farmers using polyculture methods. Even urban planners took note, exploring how flooded rice crayfish plots could be incorporated into future peri-urban green buffer zones, combining food production with natural stormwater filtration. And then came the cultural impact. For generations, Australia's farming identity had been shaped by monoculture, big fields, single crops, heavy machinery, but the rice crayfish movement challenged that paradigm. It demonstrated that a different way of farming was possible, one that embraced ecological balance, reduced waste, diversified income, and actually made farming fun again. Farmers no longer saw themselves as just producers. They were stewards of ecosystems, entrepreneurs, innovators, and for a sector so often associated with hardship, that rebranding meant everything. So yes, they laughed in the beginning, at the thought of mud-crawling crustaceans becoming farming partners, at the idea of harvesting claws and grains side by side. But a year later, as rice yields rose, crayfish shipments soared, and biodiversity returned to parched fields, that laughter turned to quiet admiration. Because Australia hadn't just changed the way it farmed, it had changed the way the world looked at farming. What if the solution to our biggest problems, food, water, and climate, has been hiding in plain sight all along, just beneath the surface? Share your thoughts in the comments below. Thank you for watching. See you in the next one.